Hello, and good afternoon to everybody, and thank you for joining us to our innovative digital solution session. And as we have a full house here, we have also a full house in the speaker line with those honorable speakers that I will leave them to present themselves, each one, when they will start the presentation, because if not, it will be all day long. My name is Gadi Ben Moshe. I am Managing Director of Marine Innovators. I'm also Port Network Lead at Eller, the Smart Container Company, and Vice Chair of the IAPH Data Collaboration Committee. And again, I would like to start, before I pass the floor to those honorable speakers, I'd like to start with a question. And the question is, maybe a statement and a question. I went around the exhibition today, and I saw a lot of physical solutions for ports. From cranes through cables until lubrication for machinery. And my question to you, with a raise of hands, it's still the physical solutions the main issue in ports, and more greater than the digital solution needed? So for the physical, who raised the hand? Come on. Come on. Did you see outside? So you still believe that the digital solutions have a substantial part in making the port more efficient. So this is let's make a hand for that. Okay. So great. So you don't have such a hard work convincing our audience. Okay, you can go home. Okay, but no. What I want to say that innovation, it's innovation also when we're talking about physical infrastructure or digital infrastructure. And I want to share with you, we recently in IAPH developed an innovation white paper called the Mindset Shift Towards Innovation in Ports, and I encourage each of you to read it. And also there, what we mentioned is that it's important to have the combination of the industry, the startups, the solutions providers, and in the other end to have the ports and the port authority. And this is the combination that will bring the implementation of more efficient maritime supply chain. So we have in this panel this great combination of solutions providers, of terminal operators, and we will hear these different aspects of the digital innovation. And we have to raise our voice. No, we want dance today, so don't at least not an innovation that we will do. Okay, but we will try and fight this music. So without further ado, I would like to invite Joe to take the floor, please.
Okay, good afternoon everybody. Coming. It's great to be here. Thanks to Gally for moderating the panel. So, my name's John Lane, and I'm the Senior Sustainability Manager over at RightShip. My background, I've been in the environmental game for about 12 years. I moved into the maritime sector about 7 years ago, and I've had experience working on board vessels as an environmental officer on board large cruise ships and bespoke cruise ships, on the acquisition and support space, and also now with RightShip for about the last 12 months in the data and digitalisation space. So I'm here today to talk to you about how you can use data and digital tools to reduce the import vessel emissions. So getting the insights and having the analytics into the vessel emissions import. So for those of you that don't know about RightShip, we are the world's leading maritime transparency organisation, and we provide insights into the ESG spectrum from the shipping point of view. And we do this for charterers, we do this for ship owners, brokers, and we do it for ports and terminals and financiers. And within that, we've Our history, we were set up as a vetting organisation after a number of ships sunk off the west coast of Australia in the late 80s, early 90s, and our shareholders, they decided that this couldn't continue. Over 100 seafarers lost their lives, along with the impact of the environmental loss of the ships. And so they decided they set up a vetting organisation to make sure that they hired the right ship. So we've since transferred into a data and digital focused organisation, and we've got an online platform that provides transparency into crew welfare, into safety and into environment. And within that environmental bracket, we focus on the decarbonisation space. We've got a greenhouse gas rating that provides insights into the design efficiency of the vessels. We have a carbon accounting module, and we also have a maritime emissions portal that I'm going to be talking a little bit about today. So why data and digital? When I go back to my childhood and I think if I wanted to find something out, say for example what the world's largest ship is, or who scored for Aston Villa in the 1982 European Cup final in Rotterdam, I'd have to go to an encyclopedia or a book, or maybe I'd have to go to a library or go and buy one, and that would all take time. Maybe the data is not being updated immediately, I've got to wait a year to get the information. But with modern data, you can get any information you want pretty much with the click of a button, anytime, anywhere. And this is certainly the case with the Internet of Things, where you can have insights into what's going on with your hardware, in your machinery, in a port and terminal, at any point in time. You can combine this with your smart sensors, so for example what's going on with the air quality, and what's going on with the water quality. If there's a pollution event, you can react to that quickly, you can have the insights immediately. There's artificial intelligence and digital twins that enable you to sort of strategize and develop your scenario planning to see what changes with your efficiencies can make an impact on your operations and perhaps save money, save fuel, save time. And then there's the automation and robotics, and we saw this on the port tour yesterday, the fully automated tour, the fully automated port down in Rotterdam. And of course with this as well is the added complexity of cybersecurity and the need to manage and control all your data. So I'm looking at the emissions from the vessels in port. And you might say, well, why look at the emissions of the vessels in port? Surely the biggest impact of shipping is through the transit leg. And through the data, through the 4th IMO GHG study, this is the case, that the majority of the emissions do happen during the transit leg, but that isn't to say that it isn't worth looking at what's going on in port. And ports and terminals can really have an impact on this. It takes me back to my shipping days when I had to make my environmental route planning, and you'd have regional requirements, national requirements and port requirements. So for example in Italy, they wouldn't allow incinerator use within their waters. Or in Lisbon, you'd have to deballast before you went into the port. In the Baltic regions, you're not allowed to use scrubbers. And it really shows that although there is the macro level in terms of the decarbonisation and air quality challenge, there's also the ability for ports to introduce their own requirements for the ships to comply with. And this goes into the regulatory requirements. Of course, there's additional things coming in now in terms of managing and reporting on your Scope 3 emissions. There's the need to understand what those emissions are. So have you got a trusted source of data for those emissions? Have you got a tool that you can use? Is it burdensome with time? There's additional stakeholder pressure from the port communities. They want to know that ports are doing something, particularly on the air quality side, but also increasingly on the decarbonisation side. And there are things happening. There's green corridors popping up, and these initiatives are growing. And there's net zero goals that you'll see in various guises for different operations and organisations. So how can you do this? How can you get an insight into what's going into your port? Well, RightShip's developed the Maritime Emissions Portal. And this is the world's first of its kind. It enables port and terminal managers to get an insight into what's happening at a particular vessel on a particular day, at a particular point within their port. And they can get the insights into the 3 core greenhouse gas emissions, CO2, methane and nitrous, and air pollutants, so SOx, NOx, PMs, VOCs. And they can use those insights, rather than messing about with heavy data sets, to use it to get the analytics and develop a strategy. So how do they do this? Well, first of all, they need to define what their scope is, what their area of interest. And they draw a geofence, as you can see on the right-hand side of the screen. And they can say, right, this is my points of interest, here are my anchorage points, here are my transit zones, here are my manoeuvre zones, and here are my berths. And within that, RightShip's got a a unique vessel database of over 200,000 vessels, including the engine characteristics, the specific fuel consumption, any investment in energy-saving devices and equipment, and we combine this with AIS data to kick out a number of insights. So it takes away the effort from the data processing and enables ports to look at what's going on. So this is through a number of things. It's through dashboards that can provide you a high-level insight, so you can break down your GHGs and your air quality. You can look into which ships are contributing the most emissions within port, and you can track how you're performing on a monthly basis. So if you're a seasonal port, you can see what you might do in different regions at different points of the year, and you can track it year on year as well. We have an innovative heat map technology, so if this is the way you like to learn and see insights, we use a RAG system for the areas of the port that might be having a specific impact. So in this example, you can see the anchorage points. There's a number of red areas, and you might tie that in with a digital twin to try and improve the speed of the vessels coming in, so that they're not all coming in at once and hanging around at anchor, and you can try and, therefore, if you're slow steaming as well into the port, you're reducing the emissions from the vessels. Also, with the heat map, you can look at the what's going on in the berths and terminals. So if you were looking at onshore power, for example, and that's a big push through to 2030 within Europe, you might decide that you might think that one terminal is a particular pain point, but through using this, you might find that actually another one's a better one to focus in, and you invest in that instead. So to develop your strategy, you can start looking into the high level. And say you can look at your pain points through the heat map, and then you can start to develop your strategy and targets. So it might be for all of the vessels in the port, but then you can break it down into the specific vessel types, so for cargo, for example, and then within that you can look at the different vessel deadweight tonnages as well. So you may have a particular NOx problem with one type of deadweight tonnage, or a SOx problem with another, and so on and so forth. And you can really look into that and set your strategy. You can then start to drill into the data further, and you can see at a particular operational mode, so this may be at anchor, alongside, manoeuvre or transit, and the specific emission type, whether that's CO2, NOx, SOx, PM, and you can then start to drill into the data with that. And you may have a particular problem at a particular berth, and again you could start to say, well, why is that happening? If you combine that with your Internet of Things, if you combine that with your monitoring of your hardware and your machinery, and you could say, well, this piece of machinery is breaking down on a regular occasion, and then you can start to build that into your maintenance schedule, or your procurement schedules as well, and that can improve your efficiency, save fuel, and save energy. You can also use the insights to see which are the highest emitting vessels within your port. So that doesn't necessarily mean they're the worst vessels; it just means they're the highest emitting. And then perhaps if you're investing in onshore power, you're going to start engaging with those vessels and say, well, we want you to electrify, and then we can hit 30-40% of our emissions in one go over a 12-month period. You can introduce incentive schemes as well. So RightShip has the GHG rating. It's an A to G scale which rates vessels on their design efficiency. And some ports are doing this. They're saying, well, A-rated vessels, B-rated, they're good. They're going to get a port discount. Whereas the F and G rated, they're going to have to pay a small fee, and it's a self-funding scheme, and it's incentivizing ships to invest in their energy efficiency and their design. So an example of how this has been happening was in Prince Rupert over in Canada, and they were using all these insights to actually develop their green wave strategy. So that involved RightShip's GHG rating, it involved the ESI that AOPH use to try and encourage ports to improve their design efficiency. They also looked at their anchorage points and were able to reduce their emissions by encouraging ships to slow steam in where appropriate, and they're using it to develop their strategy further on. So they're able to identify where they're going to invest in onshore power and track how they're performing against their targets as progress continues. So why look at data and digital solutions? Well, at the moment, a lot of people are using data-heavy spreadsheets, and this data and digital solution really takes the effort out of that. It enables ports and terminals easy analyticals to design, develop and diagnose their decarbonisation strategies and track how they're performing against that on a monthly and annual basis. They can act and identify on hotspots. It can be combined with the other parts of the digital jigsaw, whether that's a digital twin or an Internet of Things, and they can use it with scenario planning as well to see what their strategies might look like in terms of decarbonisation in the future. They're also able to use it to promote to local stakeholders that they're actually taking action in terms of decarbonisation and air quality, and they can use it for attracting financing to the right areas, green financing. So that concludes my presentation today. Thanks for listening. We're based over at C4 if you want to come and chat more and learn a little bit more about the tool. Thank you.
Thank you, John, for your interesting presentation. And I would like to share one takeaway that from your presentation, in my understanding, it's that emission, taking care of the emission, is a role for everybody in the supply chain, and maritime supply chain. And as you say, the ports need to know what is happening emission-wise in their ports and do something about that. If I may, before you come back to us, a question. Talking about the ports, how they can collaborate to help us push this environmental agenda further?
Yeah, it's a good question. So, every port is unique, every port has its own challenges. You have the macro level of the decarbonisation and air quality, but they all have slightly different operations. They're at slightly different points in terms of their evolution of their reaction to the sustainability challenges. So I think ports can work together to identify and sort of highlight strategies that they've introduced and challenges that they've faced in terms of decarbonisation. Certainly in terms of the insights to the vessel emissions, ports are using this type of tool because this type of transparency and data into vessel emissions isn't readily available. So we're all facing the same challenges of the net zero and air quality problems. So it's you know, we are about transparency, right ship. We're encouraging driving towards a zero harm maritime by 2050, and we think by collaboration ports can share best practice and encourage each other on the journey.
I understand. Thank you. Transparency is not only about where is my cargo. Transparency, it's what happens with emission in the supply chain. Yeah. Thank you very much, and don't worry, we will be back, and you will be able to ask questions to the panel. But now I would like to give the floor to Marco and Dimitris, and we will do musical chairs. And please, Marco, the floor is yours.
Hello. Good afternoon. So we'll try to stick at the timing. Thank you you all for being here. Thank you to TOC for organizing these sessions. So innovative digital solutions. This is where we are. We would like to talk about predictive analysis in container terminal operations. So first, just a quick presentation introduction to DSP, just to let you know who we are. It's a consulting and IT company. We have four main offices. The headquarters is in Switzerland, then we have a company in the Netherlands, is Peter Loomis, a branch office in Chennai, and an office in the DSP America. So we are basically a team of industry expert consultants trying to solve problems. So our core business is around TOC consulting services, and it's about defining business process mapping, doing optimization, testing services, configuration of your TOC. Business intelligence, that is about understanding your data and your KPIs and see how things can be improved and monitor the operation. And finally, we moved into the digital twin world with our product named Gemini, which is the argument we are going to talk about during this session. So when we speak about digital twin, I think it's good to refer to a platform rather to a single product or a single solution. So we see our solution as a combination of different tools that can provide predictive analysis, simulation, emulation testing, 3D view, or virtual commissioning of equipment. So what is common in all these different tools is that you need a model, a digital model of the reality. A model that describes what is happening. The way this model is designed and presented, it's based on your actual needs. So this is always important to start with a detailed analysis of the requirements and understand what are the expectations. Now we will focus on the predictive analysis and just a few examples of what are challenges and objectives that could be achieved through a predictive analysis exercise. So it could be about optimizing or seeing what is going to happen to the birthing process in terms of both birth occupancy, but mainly in ship-to-shore crane utilization. What is the best working plan for my cranes? What are resources that are needed to service my customer and whatever should be done based on historical data, based on actual data, and see what's going to happen in the future to support decision when calling new shifts, when engaging new resources. All this consideration that can have a wide broad, including not only the vessel side, but of course the gate, where we can play with appointment rules, for example, the rail, but even the equipment maintenance to understand when you can actually put the equipment at disposal to the technical department for planned maintenance. All this consideration can be done in the short term, meaning we are looking ahead in the future of one shift or two shifts, so that we are really have a very accurate model that can help us in taking operational decision, or looking long term, more for forecast for volumes, of financials, having a more structured approach to our future. I would like, since we are talking about a concrete use case here, and I'm really pleased that our customer CSP Valencia is with us and will tell you about the project itself. I think it's important to tell you about the implementation, because we see a lot of presentation, we see a lot of how it's nice to have a digital twin or to have this digital intelligence, let's say, in our reality, but how to implement it. So I would like to share with you the experience we made in this case. And I think the first point, as I was mentioning, is setting the objective. So know the challenge, define the objective, and even set the expectation. This is the most important part of the project, because on that your technology vendor can really build the model based on your needs. The first point is collecting the data, and it's about taking the data from your TOS in this case, or other database systems depending on the requirements, of course. Having the historical data available to build the model, the statistical model, and to have more accurate prediction, the live data. For doing this, we built connectors to the terminal operating system. Nowadays, our Gemini is capable, it's a sort of plug and play, I would say, with N4, with KTOS, and with master terminal already, but of course we are open to any other TOS, and even to any other kind of database in case you want to add information from HR, from technical department, or financial, or whatever. Once we have the data, then we can create the predictive model. That means really doing the digital exercise of creating these entities that it is true are standards, but in any case must be tailored on your reality and your operations, depending on your operational model, which kind of equipment you are using, which kind of path you have, which kind of special process are currently deployed at the terminal. This must be, in any case, a tailored solution. Then the next step is validating the predictive model. That means you have it is quite heavy, I would say, this part, because it does not give you immediately the return, but this is absolutely needed to tune and give you the trust in your model. So you have to do your prediction and then track if the prediction was correct based on the actual conditions. So what we were able to achieve on an 18-hour look ahead prediction, it's 98% reliability, but more important, how it was built, the system, is that it's very fast in running what if scenarios. So when you change a possible scenario and you change the conditions to see how to act on improvements, we are talking about milliseconds, so it's very quick. So at that point, you can run your what if scenario and your decision support. So if I would like to improve an aspect. And this, of course, will bring to continuous improvement. How it's basically mainly running this improvement. So the product, it's a product, so there is a roadmap with standard functionality that will come available to all customers. But of course, in case of specific requests, there are customizations that are deployed based on the demand. So the product will become richer and richer the more you use it, basically. And about the duration of such a product, I think we can fairly say if we stay to a standard, so using one of the existing plug-in and the standard dashboard provided, it's a 6 months product. Of course, the more customization are needed, the more it could take to get to the results. So the look and feel of the solution is basically a dashboard. So KPI dashboard shows in real time what is happening, and it tells you about the past and the future. You can see a birth planning and then graphs. This is basically what you see. We are not talking here about 3D visualization of the terminal, but simply about KPIs and numbers and figures to help you in your decisions. Now I would like to hand over to Dimi, who will tell you directly about, from his experience, how it's working with such a tool. Thank you very much.
Hello. Good afternoon from my point as well. My name is Dimitris Zoulos and I work for Costco City Port Spain as a process equipment engineer. Part of my work is to work on the projects and the continuous improvement of our business units. I would like to start by sharing some generic information about us and who we are. So we are based in Spain and we operate 2 deep sea terminals, one in Valencia and one in Bilbao, plus 2 inland rail terminals in Madrid and Zaragoza. Apart from the terminals, we also offer transportation services by having a rail operator company that is providing the locomotives and the wagons, and a rail transportation company that is booking the rail equipment to transport the goods. Our goal as a company is to provide high quality services to our customers in our terminals, but also to offer alternative and efficient connection options between the 4 sites, but also to the rest of the hinterland. In the picture you can see a top view image of our 2 deep sea terminals where we offer total annual combined capacity of almost 5.5 million TEUs, and we operate the terminals by using a total of 28 key cranes, yard tractors for the horizontal transportation, and a mix of RTGs, lead stackers and empty handlers for the yard operations. In Bilbao, we operate the rail terminal by using 2 automated RNGs, and there is also a rail OCR. In both sites, the gates are fully automated and equipped with a gate OCR. And now we come to the case of Gemini that has been developed for Valencia. As Marco mentioned, we have information that Gemini is able to combine. And these are the historical data such as productivities, yard, rail, gateway patterns that are constantly recalculated and fed into the module, improving the accuracy. Then we have real-time data, such as completed pending moves, vessel plan, rail schedule, and these are important in order to identify the workload for the next hours, but also to see how well or bad we are progressing during the current shift, because this also has an effect on the estimation. And finally, but very important, is the experience of our users when it comes to configure and set up the module. This is the key. So with these 3 in place, and let's say by using a simplified KPI where we freeze the time and we get the expected workload productivity per vessel for the current and for the future ships, and we compare this with what happens in reality later on. We see that for more than 85% of the vessels, we get accuracy levels higher than 85%. And in the cases where the vessels are in the lower accuracy range percentage, there is normally a good reason why, such as we have the unpredicted delays, unpredicted breakdowns, weather conditions, and so on. Apart from that, Gemini is recommending how many resources we need to use for each shift, and the user can instantly create what-if scenarios to see what the effect will be on the operations plan if we change this number. And very important for us, with the current version we have, there are some new features. We want to focus on identifying possible bottlenecks in the yard, such as busy areas, in that way being proactively and review the plan and adjust it when required. Each terminal has its own structure and roles in the operations department, and in our case we see Gemini being a useful tool for operations department, but specifically for roles like berth label planner and shift manager. Because through Gemini they can get important information that is key for their daily tasks, such as reliable predictions, operations and labor resources planning, real-time KPIs and how these will evolve over the next hours, anticipate challenges and try to prevent them, and generally Gemini can also be a shift handover tool, since all the information is fed in the system and giving the user a global overview of the next hours. In terms of where we are currently, we have many features that have been developed, tested, and proved the value. We have a key user that is in the role of berth label planner that is creating the plans and the scenarios on a daily basis. But at the same time, we're also testing some new features that are under development, focusing at the moment to enhance the global vessel planning visibility and overview, and also to anticipate bottlenecks. So with these two, when we're going to have them ready, we plan also to start rolling out the application to more users, such as the shift managers. But there are also items that are in the roadmap. I will only mention a couple of them that are important, such as the integration with gear planning, so we can also run simulation models, and machine learning opportunities, and also to connect to other applications in TOC, such as the CMMS of our engineer department. As a last comment, I would say that like in every application and every software, the more users there are, the more ideas and better will be. And together with the advances in technologies and IT, this will contribute to the continuous enhancement of such products. Thank you.
Thank you, Marco and Dimitrios. I take maybe two takeaways together from both of your presentations. It's from you, Marco, that you are playing. Okay, you are playing to answer what if. What if I add another train? What if I add another lane to my gate? And so we are playing. And Dimitrios, I understand that playing, it's paying off. Okay, so it's great to see great solutions when you're playing. So this is my takeaway. But a question, to each of you, because if I understand right, your terminals, you say more than 5 million TUs. Okay, so in Marco or Dimitrios, in your opinion, it's the solution also can fit to smaller ports than that, or just your opinion?
Okay, yeah. So I think it's a solution for all type of terminals, because in every terminal, the terminal can be efficient in two ways. Either we can do the same with less, or we can do more with the same. So the first can be achieved when we get spot-on labor requirements, and the second can be achieved, for example, when we have an optimal operations plan, or we can anticipate bottlenecks. So based on this, I think all the type of terminals can benefit from this.
Okay, thank you very much, both of you, and we are more questions later. and we are keeping on playing our musical chairs. So Joe, take the floor, please.
Thank you, everyone. Let's see if we get rock music during this presentation, like the last one. So my name is Tor Torup, Chief Commercial Officer and one of the co-founders of PortChain. So founded the company now 6.5 years ago. And what I'm here to talk about today is basically a little bit of an update on our Birth Alignment Network. Last year at TOC, we formally launched our Birth Alignment Network, you could say, in the market to everyone here. And we want to give an update on what that is and how it's going, and some of the values that terminals and carriers are taking away from that. So maybe just a little bit about PortChain. So what we do is really focus on you could say, the challenges and inefficiencies that occur in the interface between terminal operators and container carriers. And we focus on the challenges that really are related to lack of high quality data, poor collaboration, and quite, you could say, manual ways of working. And all of these challenges combined cause a lot of waste, both on the terminal and the carrier side. And what we're really focusing on is how can we address that challenge. So before jumping into a little bit more about the problem, what is the opportunity? So I think we've all been talking about, you could say, what's the possibility of reducing emissions? How can we make through better operational decisions, how can we actually achieve better outcomes for the environment, but of course also for the bottom line. And recently, the IMO have done a lot of studies on what's actually the value of sharing data between terminals and carriers and ports, doing that more structured, doing that more timely, doing that more coordinated. And they estimate an almost 6% reduction both in CO2 emissions and bunker consumption just by aligning the port call 24 hours in advance of arrival. If you do it all the way, say, from the previous port, that potential is all the way up to 14%. So this is an enormous opportunity that through better data sharing, through better coordination, you can achieve a higher degree of berthing on arrival and getting rid of waiting time and making sure that vessels sail and arrive just in time. So that's really a big opportunity, and that's really what we are trying to address and support. So if we go into a little bit the details, so you probably, all of you have heard about just-in-time arrival, but how do you actually achieve that in practice? What are some of the challenges you need to actually overcome? And basically, one of the key challenges in the industry today is the berth alignment process. So actually the process of sharing data between terminals and carriers to agree on an arrival time and a departure time. So basically that alignment and agreement on the berth window. And today that process is extremely manual. So you have both every carrier and every terminal, they are sharing data through spreadsheets, PDFs, and phone calls in a different manner in every different port. And a terminal operator will receive 5 different kinds of spreadsheets, different kinds of teams they need to work with. They'll get a call from the headquarters of a carrier or a regional team or even a local agent. So they might sometimes have conflicting information, and when you need to then plan your berth plan to again make predictable operations, what's the latest data that you can trust? It's also a process where it's quite hard to keep track of changes. You have many planners out there will have a completely flooded inbox, and not knowing what's actually the latest change and why did this happen? Why was the vessel delayed? Why did it end up waiting? Or why suddenly was there 500 extra moves when the vessel arrived alongside? So these are all some of the challenges that are causing, you could say, are some of the blocking points of actually achieving just-in-time arrival today. So what do we actually do with PortChain? So what we try to do is actually create digital handshakes between the terminal and the carrier based on the most up-to-date and trusted information from both parties. So what does that mean? We basically connect, one is the system layer. So it's actually connecting to the carrier's scheduling system, their cargo systems, to get the most up-to-date information about when that vessel will be there and how many containers it's going to be offloaded and unloaded. Conversely, on the terminal side, we connect to either the terminal operating system or the berth planning system to make sure that the most real-time berth availability is there. To then avoid that, you could say you have different versions of the truth, we do the change management of supporting a carrier to say, okay, everyone involved in this scheduling can actually now augment the data. So the key planners on both sides, terminal and carrier, have access to both the system information, and they can then augment that data with more information. They might have some local constraints, some local conditions they know, they can add that on top. And that's basically one source of information between the terminal and the carrier, where they commit to say, this is our latest information, this is how we make decisions, and that's how we do our planning. So a terminal can basically get started very easy. So we've done everything we can to make the adoption as easy as possible, so we can see value quickly. So that means we have, for example, a user interface you can start by replacing your manual phone calls and emails, and then you can quickly see the benefits, and then you can decide to integrate, where you can then integrate in many different ways depending on the architecture and capabilities that you have. And one of the key benefits for terminals is basically getting more timely and accurate updates. So as soon as an update is made in a scheduling system, that will actually flow through. So instead of getting an update, let's say once a day in a spreadsheet, and then getting multiple phone calls during the day, and sometimes with a delay, or sometimes someone is sick and then you didn't get it, this is now consistent and more reliable stream of data for your company. So as I talked about, I wanted to give an update a little bit on what's happened with the network. So this is from last year, June 2022. We started the year with 3 terminals on board, and managed to onboard then 17 terminals on this process. In terms of carriers, Hapag-Lloyd was the first shipping line to say this is what we want to now deploy and deploy that globally in all their terminals. And that was really the status. And of course, to make a network attractive for terminals and carriers, the terminal wants all their carriers on board, and the carrier wants all their terminals on board. So that's really been our focus. So in the last 12 months, we've basically gone from the 17 to now 68 terminals on board in every single continent. Here's a few examples of some of the terminals on board. And at the same time, we have also onboarded 2 additional top 10 shipping lines. One that I can mention is Evergreen, who are now also, you could say, coordinating and digitizing their process through the platform. So really the goal is to make this extremely easy to come on board and very quickly identify what kind of benefits there can be in terms of digitizing the process. So roughly 3% of all vessel calls are now coordinated live through Portchain, and with more carriers coming on board, that could be up to 16% in terms of the coverage on the terminal side, which of course is a big focus for us. So I think just to talk a little bit about, and I know Gadi asked us about how do you actually implement, make this a little bit practical. And so I'll first talk about like what kind of benefits you get, because to actually go forward with implementation, you have to quickly also see benefits. So really the first area is just getting increased data quality and frequency. So making sure you get the latest information timely and accurate. That's sort of the key thing, and that's one of the key benefits that why terminals join. So they can very quickly get access to the latest data source. And on top of that, we add different kinds of validation of the data. So for example, if a carrier sends a timestamp that says we'll be there Monday 1400, we can also predict and say, well, even if that vessel is at full speed, we know that we'll never make it. So those are also the kind of validations we add on top to give more confidence in the data and ultimately help increase the accuracy of the data. The second part is around saving time and effort. So just all this manual phone calls and emails and looking at spreadsheets, looking what changed, that's also just a thing of saying, okay, let's just get it in one place and see what changed. And then the third part is around how can we actually increase alignment and get more reliable plans. So by having everything digitized, you can actually now start measuring the process. When it's a phone call and email process, it's hard to measure. It's actually hard to improve. When you can measure it, you can actually drive improvements and be more targeted around it. So ultimately, what are we trying to help with? We're really trying to both lower waiting time for the vessel operator and also help terminals improve their utilization of their assets. So, how do you then get started? So I tried to make it quite simple in terms of this is basically our onboarding process. 5 steps to full, you could say full usage, where after already step 3, that's when you're live. So basically, there's both you start off with just a joint introduction that's together with the carrier that you want to start with, and you understand a little bit the platform. We map out then the process, what's your current berth alignment process, what are the things that are being shared, how are they being shared, what is the scope of digitization, and then we always typically start with a trial. We want to make it easy to get going and quickly identify the benefits where a terminal can then, in the end of the trial, say how do we want to continue. And typically we do that just in 6 weeks, where in that 6-week process we basically replace the existing process with a digitized one. It's a change management exercise also, so we try to say, okay, to build trust in the new way of sharing and receiving information, and we see typically that takes 6 weeks. After that, most terminals, they come and ask us 2 questions. One, we'd like to now integrate to our TOC, so we can send the updates real time from our side to yours. And the second thing is bring on board more carriers. And that's of course a big focus. And then basically after that, then that's basically the new way of working, of sharing and digitizing that process. So that's really the sort of the 5 steps to get going with working like that in a new digitized way. So I think that was that's a little bit what I wanted to give you an update on here today. You're very welcome to come and visit us at our stand at G10. So thank you very much.
Thank you, Thor, and thank you for listening to me and explaining the implementation side, because it's very important. I have one statement that I want to do, because we at the IAPH work a lot, mainly in the last years, about the just JIT and PCO, just-in-time arrival and protocol optimization. It's something that everybody's talking about that, the BCSA. We did IAPH together with IMO, we did the symposium in London. But what I always say that, okay, great, we have to implement now. Okay, we talk about that. Here is here is the standards and the best practices. Now it's time to implement. Stop talking. And I'm happy to hear that you're already implemented, and that in 1 year going to 68, it's great achievement. So kudos. And a question, if I may. And it's more about sharing or cooperation or about information. It's something very tricky. Confidentiality of information. This is one of the challenges. So, as a terminal, when you approach me, how can I be sure that my information doesn't leak to other terminals or to somebody that I don't want them to get this information?
That's a great question. So I think really the key is that you could say you control who sees your data. But I think that the main way to think about it is we're going in and replacing the existing data sharing process. So as a terminal, you will receive, of course, information from all your carriers, but a carrier will only receive data for their own operated vessels. So there's a very strict access control in that sense. So it's really, you could say, supporting the existing ways of sharing data that are already shared today, just in a much faster and easier way.
With this explanation, you get okay. You have to work out. It's not only one sentence that you have to say today, isn't it? Okay. So thank you very much, Thor, and I would like to continue our. We are here. I remind you, when we started, we are trying to convince you that digital solutions are very important, not only the physical. I reckon that we are on our way, but we are halfway through. So thank you very much, Thor. And I'd like Jennifer, please, to take the floor.
Good afternoon, everybody. I'm Jennifer. I'm from Orbit. I have 10 years of work experience working in the maritime and technology industry in companies such as Maersk, Honeywell, now in Orbit. Today, I'm going to present how to digitize cranes with deep learning in computer vision. So, after talking with many ports, we discovered that the cranes operations can be more efficient. So ports ask themselves, how can ports optimize the productivity of cranes operations? We have some answers here, let's think together. We have one option. As Gary said, should we keep investing in physical infrastructure? Shall we have more cranes and buy more? One answer to this could be, but space is limited. There are no space for this. We have an option too. What about replacing old cranes with the next generation cranes, such as the ones that we saw in the port of Rotterdam yesterday in the port tour? Some of us saw it. These are fully automated and autonomous, but some of the ports and terminals cannot afford that. So we think in an option 3, what about using the existing cranes, using the existing infrastructure? Today, AI developments are able to break us free from hardware dependency and allows us to use technology and add an AI layer to the existing infrastructures that we have. So in Allread, we are developing solutions that with minimum hardware add-on and the power of technology, we can do the track and trace of container in cranes operations. How it works. So our technology is based on deep learning and computer vision. If you see this picture right here, what the audience would say. What is this image, for example? It's the classic Beetle car, Volkswagen, right? What about the second one from the panel? What do you think? Yeah. We still agree that this is a car, right? And what about the last one, the third one? You want that? Okay, Gary, this is the last Mercedes Vision AVTR, the car of the future. So here in this simple exercise, we as humans are able to recognize these images of cars. We know that they have the characteristics and attributes that define them as cars. And how we do it? Thanks to our brain. So our brain has learned through experience, and after seeing so many pictures and cars in real life, we are able to classify them in the semantical class as cars. Computers work the same. It is computational learning. So here it is a data-driven process that aims to statistical models that actually we've been talking about, Marco said that as well, that are able to generalize and recognize patterns in images, in this case, with different appearances. We applied it to ports. So our engineers developed artificial neuronal networks that are able to digitize any asset of ports. So trucks, wagons, containers. Here you see our black box in action. So for example, in an access control, anytime that a container goes through an access point, our software processes all this data and transfer these images into valuable data for the customer, container codes. And we do it providing high accuracy. How we reach this accuracy? With training. So besides gathering real data from world, we create synthetic data. So here you see some examples of containers. We change the letters, the numbers, then we augment data. So we make some small changes by adding more color, changing the color, brightness, contrast, etc. All of this because gathering and having data is time-consuming and expensive. And we need massive amounts of data to have the most robust models to read what we do today. And not only that, we have trained our neuronal networks to be able to read in harsh conditions. So in this case, you see a container number. Usually data is not perfect in this shipping world. So containers are with blurry, with partial damages, with occlusion, etc. And for example, even this wagon that is not that clear, we can even with graphitis on it. So it doesn't matter that is that damage, that the condition is very hard, we can read it. Why a software company such as with a technology such as ours are in the port industry right now? So anytime we talk with the ports and terminals, we still find out that they still performing manual tasks with the whiteboard, the Excel, pen and paper. For them to access to this type of solution is very expensive because it's very hardware intensive as well. Or they have a solution but it's not performing in the real way. Here in our rig, we want to disrupt what it is in the market today. So in comparison of what we have, of the existing solutions, then we want to bring a more lightweight solution that with less we do more. Here is the image. So with only 2 cameras, a server, and our software, we can track a container and a truck in any entry or exit of reading point in the port. How we apply this in a tangible case today with the CTS case with cranes. So today they have 3 cranes, river cranes. They do 200,000 crane handlings per year, more or less. And their problem was that when they were handling the containers, they have some risk of errors. But they were looking for a solution, but indeed didn't find a solution that solved the problem and still protects the return on investment for them. Their expectations now in the existing process. This is the typical process that they have: the loading plan, integrated storage system, then executed to the crane's operations. The problem here is the risk of error, because the error was not detected on time. So when they find out, the container already left. It was in another terminal. What were the expectations of the terminal? So besides controlling the entry and exits of the containers, we needed to ensure that the seals were on the containers and provide proof of conditions of the containers, taking pictures of all sides of the containers. Why? To reduce cost of errors and have a better use of resources and time. So here I will introduce our 30-year-old river crane. It's almost my age, and it's very simple. We put 2 cameras, 1 server, and our software. This is the old grid style. Very minimal hardware and the power of technology. We were able here in this case to read under all conditions. So here you see backlighting, distance, if it's near, if it's far, watermarks in the lens on the camera, sunset, sunshine, all kinds of lightings, blurriness, and even if there was like a shadow or it was dark. So we read day and night. Other challenge was the crane movement. So you see here that regardless of the container, the position of the container in the image, we are able to catch the boat in the middle, in the upper side, in the center, in the lower side. So for us, all of this is thanks to our robust reading models that we have developed. And today, the operators are using this monitoring panel to supervise all the operations, so they can see the containers, reduce the errors, and have immediate action when needed, reducing all these mistakes and the cost associated to them. We keep improving our models, so today we are able to detect the seals. Here on the air, as you can see, we are reading the containers in movement, and with the same 2 cameras. Now the new process is the same load plan, with the same TOC, with the same operation of the crane, but there is no mistakes today. And we are able to provide now a process with no friction, without impacting the customer's operations, this infrastructure with low hardware requirements, that is like a plug and play. Now they don't have these issues anymore, they detect the errors before shipping, and have the proof of condition needed to complete the operation. How we have applied deep learning in ports. Here are some projects that we have worked in Europe and Latin America. For example, for roads, in the port of Bilbao, using the existing cameras that the port already have, with only one camera, we are able to read container codes, the license plates of the truck, of the trailer, identify dangerous cargo, and even do seal detection with the same camera. We do a free flow, so here with only one camera, we are able to catch the codes up to, with the speeds up to 60, 80 kilometers per hour without stopping the truck. This is in Chile, in San Antonio. So it doesn't matter where the license plate is. In the door, you see here that it's going to appear in the right, and after the license plate is going to be placed in the center. We are going to find the code and deliver this data to the client's stores directly. For the rail, for example. So we developed a solution for the Port of Barcelona to deliver the map of the train. So anytime a train passes, the operational director, Kim Tonta, and here you see a representative of the Port of Barcelona, receives a file with all the information of the train. Wagons, container codes, timestamps, etc. Here we are using CCTV cameras to do the sensibility of double-stack containers. And in Valencia, we have the same solution to deliver the map of the train. So we have many configurations for the rail, and we can also work with cranes. Here, only using one camera, we are able to detect the codes in movement when a process of charging containers from vessels operations. And this is the last one, the case in Hageka Cargo, which is the one that I presented today. As you can see, we read these codes in the fly with only two cameras. Today, we are present in many countries around the world. These are some customers that have embarked digital transformation with us, and this is our invitation for you. We will keep with our mission to democratize access to new technologies, such as the one that we have in the ecosystem, removing financial barriers, and also, and mostly for us, helping to close this digital gap in the industry. So that's it from my side, and you are more than welcome to visit us in our stand, J6.
So we are sharing now, sharing information, sharing knowledge, so let's share also the microphone. So first of all, I think that you gave us the bridge to the question that I had at the beginning of our session, physical or digital. What you're saying in your presentation, if I understood right, that you can use the digital to enhance the physical. Okay, so we are the bridge to that, to your solution. And a question that I had, because you show us what you achieved, but I'm sure that we are a very conservative industry, ports are very conservative, and you had a lot of challenges. Can you share with us a bit of the challenges and maybe also opportunities that you found along the way working with our industry?
Thank you, Gary. So I will focus this time in the opportunities instead, because I think that the technology has lots of potential to free us to the existing way of doing things and create new ways. As you saw in my presentation, we can use what we have and add a layer on AI to improve processes, to remove barriers for many ports and terminals that they don't have a technology today. So if we think about a small port that we also asked in the beginning, usually small ports, they don't have the budget to acquire this type of solutions. But if we give them the opportunity that with a different way of doing things, access to technology, then we are disrupting. We are breaking paradigms in the port industry. So I think this is a very good opportunity to allow everybody to embark on the train of digital transformation. And for example, for smaller, medium ports that they already have something, we can use their existing infrastructure without impacting on what we have, their processes, and actually improving them with AI. For bigger ports, they are also welcome to join this, this journey, because sometimes they have secondary accesses, but they don't want to invest that much, but still they have a problem to solve. And here we provide a solution, a cost-effective solution that can be implemented in a more agile way, so you can see the return on investment faster and still solves the problem. So I think these are the three opportunities for all sides of ports and terminals that we must consider when acquiring a digital solution. And I invite you all to give a reflection of this. And if you have any other question, again, I am in standards.
Thank you, Jennifer. We continue with Paul, Norbert. Please, the floor is yours.
Yes, hello. It just did microphone a little bit. So, hello, my name is Paul Kuppert, and I'm working for Euroway Technical Services since 4.5 years, mainly on automation and digitalization projects. And at the moment, I'm the project manager for our digital twin project, which is called TwinSim. And this is what I wanted to present today to you. So, the digital twin which we built is a project together with the University of Hamburg, and we have also Aquinet on board as a partner, and Eurograde IT, and also our technical services department. And we have co-developed, which are one of our solutions deploying things on our digital twin. So let's go through. So what have we on agenda? So the first thing is what I want to talk about is how a digital twin can help us today. And the second one, what I will explain is, and we will go more deeper in the technical solution, is what can digital twin looks like today. So we go into a cloud solution, and that's more different than other people doing, and that's what I will present. And later on, Norbert from Aquinet will present you the visualization, optimization, and also the simulation environment. Okay, so what you see here on the screen is the general scope of our digital twin. So the main idea is to get all the data from chiefs, which we see here on the bottom of this presentation. And the problem which we have is here that every single equipment speaks different languages. So we have to put this in a standard, and this is what we have done. We put it all on TOC 4.0 standard. Bring this data to a central data lake and enrich this data with TOS data or ERP data like from SAP, or we can put also some weather forecast or whatever into this data and bring this together. So we fuse the data together, and then we are able to have functions which this digital twin give us to move forward and do special things. But later more about that. So everybody of you knows this circle of continuous improvement. Yeah. So we have planning, we have to do then something, check this data, and act on this decision what to do. And this digital twin gives us the possibility to do this. So everybody is asking, I have to do this, but how? And now we have the tool which is allowing us to do this. Yeah. So we have the simulation, which give us the possibility to plan something, to ask question, what if I will do this like that? What will happen? So what is the optimum of my equipment which I will have to use? Yeah. And this is the simulation part which we have in our digital twin also included. Yeah? Then we have this part of the visualization and the replay function. So we can see live what happens on our terminal, yeah. But we can also jump back. So you can jump back for a minute, for an hour, or even a shift or a day backwards, and see exactly what happens and what occurs to this situation which we have at the moment. Yeah. So that's the more the check which you can do with these. If we go further, there are even more data. So we collect data, not even just live data, but we have also historical data. And this historical data can be also used to analyze and to build KPIs and to check if our cause effects our relationships are working or not. Yeah? So that's the analysis which we can do. And we can build KPIs in a very accurate way because we have data standardized over all our terminals. Yeah, so it's the same solution, and we can use it for these topics. Then we use AI for the act part, I would say. Yeah, so we use it for better to make better job instructions. That means which equipment have to do the job instructions. Yes, this is done by an AI. So this is the part of our university which gives us here the idea of it. And there are also some machine learning algorithms which using historical data which we have stored in our digital twin to calculate what are, for example, traveling times for equipment. Yeah? So when this equipment will arrive and give us these container on a special place. Yeah, that's all the data which we have, and we use it. And this is the idea how this continuous improvement can work. Yeah? But now I want to get deeper inside, and now we will get a little bit technical. So I hope everybody enjoyed it. So this is a typical view of the G equipment. So we have a PLC, we have sensors, we have additional system like GNS or whatever, and all these kind of equipment or systems speaks a different language. So we put an edge device on this solution, and the custom interface are all collected and translated and put on an MQTT broker, which is on this edge installed. And then there are different processors which are working with the data. They are already there, and we need them for other things. Yeah? Let them do what they need. And this solution is working. But what we do then is we put this to a TIC 4.0 processor. So we bring all the data in a standard configuration or standard language, I would say, and we store it on this machine itself. In purpose if we have no network or something is broken, so we can restore the data, and we send it directly to a central broker solution, and from there to an AWS cloud solution. Yeah, so that's the way. And now I will jump even more in detail, so you can look, you can get the first look how our digital twin really looks like. So one thing forget, sorry for that. So the whole solution is built as the cloud, as the Docker container solution. So we are independent from the OS and also from the hardware. So this thing can run everywhere, and we have also the capability to do an over-air update. So how this solution looks like. So we spoke already about these on-prem edge devices, which are on our straddle carriers, on our cranes, installed and collect the data and send this to a cloud. But how is the way there? So we have the MQTT broker, which gets the TIC 4.0 messages, but there are more data which we are interested in. It's not just the machine data. So we need more. We need also the TOC system. We need the SAP. We need weather forecasting. And all this data is collected together, and it must not be TIC 4.0 at this stage. Yeah, it can be everything. Yeah, we are able to collect it because we have an open API, and also the IoT core, which is more for IoT devices to collect data in real time. And from this, we push the data to an AWS service, which is called Kinesis Data Stream, which is used for real-time data processing. And there we build different processors. So we have some input processors which takes this data and brings it necessary to TIC 4.0 format, but also we can merge the data now. So we can build from a TIC 4.0 perspective, for example, a cycle. Yeah? The cycle of machines from empty to a load and put the container back in the yard. So we put the data together, and for this we need some buffer, which is a DynamoDB, which is used for buffering the data until everything is there, and we can store afterwards this data to an open search cluster. And then the data is really in a TIC 4.0 standard, and we have the data ready for use. And here the chessboard applications come into the use, where we can access this data for historical simulations, but also live data for visualization, for 3D visualization, which really looks later out today. Then we have different other processors, functional. So our AI is, for example, working here and taking this data and using for making predictions. And the whole solution can be displayed in Grafana or in our BI tools like Tableau. And at the end, the users have the access to these tools and can use these. And that's the solution how we call Data Lake. And yeah, thank you for this. And now I will give to Norbert to give you more input. Yeah?
Yes, so my
name is Norbert Klettner, and to those who have expected my colleague Holger Schütt, who's on the agenda, speaking here after colleges and he couldn't join for private reasons. So I'm trying to take his spot. I have less gray hair, but maybe I can still convey the message there. So I'm colleague, managing director of Aquinet Port Consulting, and in this project we work together with Eurogate, the university, co-develop to see how we can implement a digital twin, and not only implement it, but like how make it use for users, create value for the terminal. And as one of my hobby horrors, you see all these TIC 4.0 points there. I'm the vice president of this association, so I'm very glad as well from that perspective to see that things, standards we define there come to life. And Holger is a professor, so he always comes with some education. So what is a digital twin there? Digital twin, I'm not reading everything, but we talk about a digital twin when there is a both directional interface. So it's not just displaying something, but you interact with the data that you interact as a service. So both directions is a key component of digital twin. Has been defined by a guy from NASA, so it must be right, they go to moon and stuff like that. So that's when we think about digital twin, that's what it is. Now, the first part that Paolo also picked on is maybe the simplest, the most obvious one for digital twin. It's a visualization of what is now. So that's more like running a movie. But that's not yet adding all the value. Yes, you will see breakdowns of equipment visualized, you will see those things in your real-time visualization, which sits on as one service on top of the data lake. But staying in this picture, important part as well is like looking back in the past. So we can rerun the visualize. So in the last shift, maybe you had that vessel operation and you want to see why. So you basically rewind your operation and rerun that in our chess1 tool and have a look where our bottlenecks, maybe you had traffic jams. So with the real information and what really happened in operation. But then you want to see like, you have a process improvement department maybe, or guys that look into that. So like, what if we would have added one more straddle carrier, or one less, or one more crane? So you can drive different strategies on your past experience. What if we changed allocations of empties, of export, and so on? And then simulate the past and see, okay, that might have been a better idea. So I take that for my next operation, the same vessel, the same service. So the learning curve is here from your past. It will support you on that. And then, well, where's the past and the present, there's the future. And so the next part is we're running with this digital twin. We're constantly running on present, and that's what it is. We cannot change it, but we can try to forecast what's happening. So you basically press a button in your digital twin and simulate the future. When does the vessel finish? When does thing finish? Based on your current information, current planning, current situation, current equipment. So everything that you get out of the real-time data of the digital twin platform from the data, you can see like where are you going when you continue like you planned and like you are currently. Now the next part, Paul also mentioned that we have from the University of Hamburg, there is AI. So now you can play those what-if scenarios, and the what-if or the ifs are then like suggested by AI. And you basically create an alternative future without actually doing it. So you're not changing yet your plan in the talk, you're not changing things in your real operation, but you want to see how the different crane setup, different work instruction dispatching, how that actually adds up to finishing the vessel earlier, or maybe being more just in time to finish at the ETD. So you can test and simulate your alternative scenarios in the future before you do. And obviously you can do that faster than real time in the simulation engine, then you can pre-run your alternative AI scenarios. That's why we have an AI-based future. So it's not the dangerous AI that everybody speaks on. We hope that this creates like good models, good alternatives and feeds that into the simulation and allows you to evaluate alternatives in the future. So, as Paul said, and that has to come on this, we talk TIC in our digital twin. We try to base everything on data standards, and then in the future we create the services based on the data that's in there, and create value for the users, so you can act better and more predictive in the future. So this is what we're currently implementing as part of the TwinZip project. If you want to know more, then you can visit us at the stand G70 here at TOC till Thursday.
Hello. So, thank you, Paul and Norbert, and don't worry, our generous host from TOC, Matteo, said that we can go on a few minutes more after 3, so please bear with us. But first of all, thank you. One takeaway that from both of your presentations, it's digital twin is a tool for continuous improvement. That's very important because that's what we are looking for improving all the time. A question, maybe similar to what I asked to Jennifer, about the challenges. Okay, because again, now you are talking about it's something that it's already implemented. For how much time already?
The project is ongoing, so we had a couple of pilot projects, and this is one where we implemented currently the Zero Gate in Hamburg.
So can you give us, in the initial phases, where were the main challenges to start with?
Yeah, so the main challenges at the beginning was especially to get all the use cases and all the requirements for these digital twins. So we spent about a half year to asking all the people what really is necessary for such a digital twin. And afterwards we spent many time to sit together and also to decide if we go to the cloud or not. And that was also an idea of it. The second thing was that after we have the use cases, we know what we want to do. We realized that the data which we need is completely in different languages, different protocols, in different stages, and some data is good, some data is bad, the quality is different. So we decided, we need to go here for a standard, and that's the TIC 4.0 standard which we use here. So I don't get the TIC 4.0 standard before this project, so I was not the one which is moving forward, but at the end it helps us a lot during the project. So we don't have to ask anybody how it should be. There's already this definition, so we go for this, and now we have really the database where all these things are together in a standard that we can use.
Thank you. So this is the magic of standards.
Exactly.
Okay. So Paul, Norbert, thank you very much, and just thank you for your passion for waiting for your time.
Good afternoon. It's always nice to be the tail end speaker on the lunch session on overtime. Nevertheless, my name is Jesper Petersen. I'm the managing director of Hamad Port in Qatar, and I will talk about a case study which we are doing right now. Or it's not really a case study, it's a project which is going live on 1st of August, where Hamad Port will take over the inspection of containers, management and operation of the container inspection facility for Qatar, which is a quite large operation. More than 300,000 containers are being inspected every year. 100% of all containers in Qatar are being scanned. More than 70% of those who are already scanned will be inspected, and around 40% will actually be emptied and restocked. Small background. Q Terminals is a relatively new company founded in 2016 by the government of Qatar in cooperation with Milaha, which at that time was the main shipping line in Qatar. The focus was originally only on Hamad ports, but since then the scope has expanded, and Q Terminals now have ports also in Turkey, in Ukraine, and more than 5-6 new projects will be coming up this year. So we're expanding quite heavily across all spectrum of the globe. There's no geographical limits. It's purely on a business-wise rationale where the expansion will take place. A bit about Hamad Port. Hamad Port is a traditional port split into various segments. There is a container part, which is the biggest part. We have a multi-user terminal. We have a general cargo part. We have an offshore part. We have a road part. And if you look carefully in the left corner, you will see the new part, which I'm going to talk about right now. The way the port operates is very traditional. The shipping line released, I'm talking about containers here, the shipping line released the container with a specific date. The data, customs have the data in their database, and they make a release of the container when the duty has been paid, if there is duty involved. And the clearing agent is then taking over the responsibility of arranging the container to exit the port. The clearing agent then book a truck, and he book a time to take the container out of the port. When he takes the container out of the container terminal, it's going straight to the inspection area, again on the left side. And from here, a rather complex process is being started. The container inspection process is totally independent of what the rest of the port is doing. So there's no match-up whatsoever. And that creates a lot of issues, but also opportunities. I'll try to highlight some of them. I've taken out a lot of aspects in this presentation for simplification purpose. There is an illegal element, there is an invoicing, accounting element, there are special types of cargoes, and there are some specific cargoes who have a opportunity to go straight out of the ports because of various agreements which have been made. So this is more the standard type of situation I will be talking about. Central Customs Inspection Area. As I said, 300,000 containers are being inspected every year and going through a process where a lot of them are being cleared by customs, but as well by many other entities. First, the container will enter the customs inspection area. When it enters, it is being registered into the customs system. It's then going to a parking place where the truck driver will meet his custom clearing agent, who will start the processing of documentation and checking that the duty has actually been paid for the correct type of cargo. When that is done, the container, meaning all containers, are going through scanning, and again going to a parking place to wait for the result of the scanning. The result of the scanning, combined with a little bit random way of doing things, also combined with what type of commodity it is and the background of the client, what track record they have, the container is then chosen for inspection or not. But as I said, 70% of the containers are being inspected and 40% are being completely container load taken out of the cargo, so the cargo taken out of the container. When there is a vacant spot, and this is on a first come, first served basis, the container moves to one of the sheds, depending on which type of cargo it is. Dangerous cargo in one area, refrigerated goods in another one, and all the other cargoes in the bigger areas. There is quite a lot of congestion involved here. All customers want normally to pick up the cargo in the morning time. I'll show some of the issues here. clients want to pick up in the morning time. And as well, we have also the bottleneck in the port. Mondays, most of the ships are arriving over the weekends, so we have a lot of bottlenecks in the process. Our target with taking over this facility on 1st of August is obvious from central diagram you can see here. Our turnaround time of trucks is significantly higher than in the other Gulf countries, and these are the ones which we normally benchmark ourselves towards. You can also see from the right-hand graph, you can see what time of the day is the biggest bottleneck. So it's quite a complex issue we have here to try to make the turnaround time smaller. Some of the solutions are obvious, and I will try to go through some of them we are intending to do. But if any of the experts here have suggestions to further improvements, you're very welcome to reach out to me directly. We're always looking for the best-in-class performance. All right, so this is the process not from a physical point of view, but from a graphic point of view. What we want to do is that when the truck enters to the container terminal to pick up the container, we will register the driver's telephone number, and we will integrate the container terminal part of the process with the customs part of the process. This means that his phone number will be used to push the process. He will be moving the container on the basis of information on his phone. We also have an app we are using, but most of the drivers still prefer an SMS because we want to be sure that they're actually doing it at the right time. We will then tailor-make our gate out so that it matches the utilization of the customs inspection facility. And I'm not talking about only to avoid the queue, because the queue is actually not the problem. The problem is that you have times of the day where the customs inspection areas are not being used. So we want to make sure that we maximize the vacant spot in the customs inspection area. We will do that by database. We will have scanners on each of the bays in the customs inspection area, so that all the time there is a digital footprint showing where should we go now, which gate should the container go to. And then we believe that these two changes, which will take out the customs clearing agent running around on the parking place and telling the driver when to move forward, going in and speaking to the customs. In this process here also we have, luckily I would say, we have been promised and we have achieved full cooperation from customs. They are actually integrated with some of the systems we are using, so the customs can see our data and we can see customs data. So we will know which commodities are the obvious one for inspection and which one by history will not be taken out for inspection. So we have a good track of trying to optimize the process. This is more on the framework here. By managing and operating the customs inspection area, we are checking out several partners in the chain. We will take out customs so that they no longer decide which container goes where on a first come, first served basis or personal connections or relations. We are also checking out the subcontractor who was there before. So it's all becoming integrated with what we do at the container terminal. This will also enable a faster invoicing to make sure that the payments are done, so that no cargo leaves without payment first. Next but not least, we will as a port take over the full responsibility of the cargo, not until gate out from the terminal, the container terminal, but until gate out from the customs inspection facility. It is so that when a third party makes the inspection at the customs inspection facility, very often later on damages are found. There could be even, but it's very unusual in Qatar. It's very, very almost unheard of that any cargo is actually missing. But there could be small damages, there could be a discrepancy in the declaration which has not been found out. So sometimes there is a vacuum in the legal part who is responsible. Obviously there will be a photo taken simultaneously with all the cargoes going in and out of the containers. So there's of course as well cameras everywhere. So we don't have any blank spots whatsoever. But the point here is that for the client it becomes a lot easier to ask for clarification in case of damages or other issues. We also have exceptional cases where cargo is being rejected and have to go back for re-export. And all this situation will now be handled by one entity and one contact point. So from the customers, we expect that the customer satisfaction ratio will at least not be lower, but because operating with customs, it's a little bit the other way around. We try not to get too many complaints. And we hope by this that we will get much less complaints and make a more successful service for our clients. We are a monopoly port in Qatar in terms of containers, but it also means that the government of Qatar is very conscious about the handling of containers. So the KPIs we have are significantly stronger than in many other, let's call it, ports with competition. And I can give an example with dangerous cargo. We had a spillage of dangerous cargo recently, which then, and it was not even a seriously dangerous commodity, but nevertheless the authorities, we had 4 meetings because of that, one leaking container, and it took like 2 months to get that resolved. So in other ports you have like, at least other ports I've been working in, you have to at least have 10-15 containers per day leaking and nobody really taking much care about it. It's more like a standard process. So the benchmark for performance is extremely high in Qatar. Last one, summarizing what we hope to get out of it. If you remember my slide, I showed it took on average 3 hours for one truck. We are thinking that if you can save an hour, 1.5 times 300,000 trucks, it will also be a quite good impact on the CO2 emissions. All trucks are running 100% of the time. The trucks are never idle in Qatar mainly because of the heating and because of the cargo commodities involved. So it's very rare that you will see a truck with a driver where the truck is actually not turned on. So we do hope that that will also have a big emission impact if we can reduce this turnaround time for this part of the containers. I think I'm getting through to the end here. As I said, there's a lot more information on the slide than what I mentioned here, so please feel free to, I assume they will be uploaded somewhere later. Last one here. Again, we want, like everybody else, we want to do better in terms of ESG. We have just initiated the ESG process as well with some very skilled consultants. We have a target like everybody else with 0 emission in year 2035, and we hope to reach that target. This customs inspection area will be part of that process. Thank you very much.
Thank you, Jesper. And first of all, I'm happy to hear that a monopoly port does a lot of things that you are doing to give a better service to the customers. So congratulations on that. And if I may mention, because your example is also an example of cooperation between customs and ports or port authorities. And this is, we are in IAPH, we are doing now guidelines together with the WCO about cooperations. And these guidelines will be published in the World Ports Conference in Abu Dhabi, your neighbors, in November. So you're welcome to join and hear about it and maybe talk about your solution also there. And okay, minding the time, and just I will give a final question to all of you, and I'll start with you. Just do you want one concluding sentence after you also heard our colleagues and about your solution, if you may?
in most countries, customs have a 500, 600 years history with traditional values and way of doing things. So it's not easy to change that. So I would definitely say that in Qatar, with a younger story, extremely focused on digital solutions, the cooperation we have had there is way better than anywhere else where I worked in Russia and Ukraine and Africa and many other places. So I would say the cooperation we have got from them is key to success in this specific project, but obviously all projects are different.
Thank you, Chester, and I will let you sit down. In the meantime, we are completing our musical chairs. Paul, the last sentence maybe?
I would say thank you for everybody to be here, and what can I say as last sentence? So I think the digital solutions which we have at the moment are showing that we can move forward and change things in this industry, and that looks forward and let's do it together. So keep going on this direction.
So thank you everybody for assisting this session. As you saw, we are bringing new things. In my case, for example, this is not a generic OCR. We have a specialized OCR mainly for ports. Our neuronal networks are so robust at this moment that we can bring very competitive value to your business. And as I said, all of this that we are delivering is thanks to AI developments. So without this, it would not be possible for us today to bring this new way of doing things.
There is a good AI, as you say. Okay, great, thank you. And
I just want to say thanks to everyone. I think for just one sentence, I think is digital solutions are here. I think many POCs have been done. Now it's time to implement.
first of all, sorry that I don't give you the floor to ask. All of them and me are at your disposal if you have any questions after the session. But last sentence.
Yes, thank you very much. Yeah, I think the message is that now the technology is there and we are capable to implement actual solution, as you were saying. And I think another thing, it's important that you can even have a budget, that our project that can start and it can end with a certain time and with a certain budget nowadays. This is our effort as suppliers for you.
Cool, yeah. Thanks everybody for your attention and thanks to my fellow panel members. I think my insight is that I can see how there's multiple insights the different tools provide, and it's how they all kind of fit together as part of the digital jigsaw to help you sort of improve your efficiencies, and on my side decarbonise and improve the quality of ports.
So, first of all, thank to all the panelists, thank for the audience, thank for the organizers, and what I hope that we convince you that next year I hope that there will be more digital solutions to enhance these physical solutions that are out there in the exhibition today. So thank you very much.